Discussing concepts and descriptions. So concept basically is a unique language independent representation of a clinical meaning. Properties, it is stable and universal. Meaning doesn't change across languages. It is machine readable, stored and exchanged via concept IDs, numeric codes. For example, this code maps to myocardial infarction, which is a heart attack. Hierarchical, they are always connected to at least one parent via ASO type relationships, except the root. Now descriptions. Purpose is human readable labels for concepts. There are three types. FSN, that is fully specified name. This is unique and unambiguous. Contains the semantic tag in parentheses, that is myocardial infarction disorder in parentheses in the suffix. Not meant for UI but for clarity during authoring. Then we have preferred term, the main label clinicians see in a given language, often FSN without tag, myocardial infarction. Synonyms are alternative names, for example, heart attack for myocardial infarction itself, marked as preferred or acceptable depending on local. So this is the example concept ID given. FSN is myocardial infarction disorder, preferred term is myocardial infarction without disorder, and synonym is heart attack. So store the concept ID, display the preferred term, but keep synonyms for search and UI flexibility. Now everything is a concept. So even relationships themselves like is a or causative agent are SNOMED concepts. Supertype relationship is a defines taxonomic hierarchy. For example, viral pneumonia is a infective pneumonia. Infective pneumonia is a respiratory disease. Now defining attributes. So capture semantic details beyond hierarchy. Attributes are relationships with the role. Common ones, finding site, where in the body. Right, so these are the defining attributes. Capture semantic details beyond hierarchy. So attributes, relationships with the role. Now common ones, finding site, where in the body, causative agent, what organism or factor caused it, and associated morphology, that is structural change, for example necrosis. These are defining attributes. And supertype relationships defines the taxonomic hierarchy, is a type relationship. So viral pneumonia is a infective pneumonia is a respiratory disease. Now example, defining viral pneumonia, right? So let me show you. Viral pneumonia disorder is a infective pneumonia disorder, has causative agent virus organism, has finding site lung body structure. Now primitive versus fully defined concepts. So fully defined concepts have enough defining relationships to uniquely distinguish them and allows a reasoner, that is description logic classifier, to infer equivalence and subtypes. Primitive are not fully defined, they lack enough attributes, they cannot be logically distinguished from siblings or parents. For example, pneumonia primitive unless further specified which site it has occurred and what is the causative agent. Why important? Large parts of SNOMED are still primitive. Reasoning is limited unless we add post-coordination or more definitions. Now talking about the expression types, we have pre-coordination versus post-coordination. So pre-coordinated have one single SNOMED CT ID representing the full meaning. This is the unique ID, and pneumonia caused by streptococcus pneumonia disorder. This is the example. Post-coordinated, we have to combine multiple concepts with attribute refinement, so we have multiple concept IDs. So the grammar is something like this for the expression: concept, the attribute, the value, and then another attribute, then value. So pneumonia disorder has causative agent virus organism, then finding site lung body structure. So pre-coordination is fast, compact, and has easy queries, but cannot cover all permutations. Post-coordination is expressive and flexible, but harder to implement and exchange. Now talking about description logic, SNOMED's foundation. So it is a family of formal logics used to define concepts, attributes, and constraints in a way that supports automated reasoning. So description logic is used to classify concepts, detect inconsistencies, and support equivalence testing. So this is the example: viral pneumonia and causative agent virus; bacterial pneumonia and causative agent bacterium. A classifier can automatically infer both are subtypes of infective pneumonia. Now, why DL matters? They ensure hierarchy is logically consistent and allows queries like find all infectious diseases of the lung. So they include all subtypes: viral, bacterial, fungal. Now the images. So let me go over the images that I have uploaded. So this is the first image. This is the description logic. So this is the example that we have. So I'll show you concept and then attribute and value. So viral pneumonia disorder is an infective pneumonia disorder. Viral pneumonia disorder has a causative agent attribute. So this is the example here. Virus organism, infective pneumonia disorder is a respiratory disease disorder. Infective pneumonia disorder is an infection disorder. Infective pneumonia disorder has a finding site attribute, lung body structure. So this is how we define the description logic. Now, next we have another important slide. So basically, this is showing us the supertype relationships. So we have components of the SNOMED CT. That is, first we have descriptions, then we have concepts, and we have relationships. These are the three bifurcations right now. Descriptions can have a fully specified name, the synonyms that are the preferred or acceptable terms that we know. So fully specified name would be like myocardial infarction that I discussed, myocardial infarction, and we always have a suffix. So myocardial infarction, once you've written, we have a suffix which tells us about the semantic tag of this particular infection, whether it's a disorder or something else, right? So this comes in parentheses in the suffix. This is fully specified name. Then synonym of this is heart attack, right? That is commonly used and commonly known for the mass population as well. So one FSN for each language we have, and synonyms we can have one synonym that is marked as preferred in each language, and there may also be a number of synonyms that are marked as acceptable. A preferred synonym is heart attack, and there are other acceptable synonyms also. Then concept, basically we have the SNOMED CD identifier, which is the concept ID. Each component has a unique unambiguous identifier, which is also machine readable, so it allows the machine to read it. And these are unique identifiers. Then we have the relationships, so is type relationships and hazard type relationships. So is basically each concept has at least one is type relationships, except the root, right? Because root does not have any parent. The root is at the top of the tree, and then we have all other concepts branching out that are sub or children of this. Then we have hazard type attribute relationships. So each concept can have as many attribute relationships needed, 0 to n, right? So this is what is explained here, and I'll show you the explanation as well. So basically, SNOMED CD concepts. Concepts are central machine IDs, have central machine IDs. Descriptions, FSN plus synonyms, and relationships, ISO and hazard type relationships. And every concept has a greater than one ISO type, greater than equal to one ISO type relationship. Each concept can have 0 to n attributes, one FSN per language, one preferred synonym, and many acceptable synonyms. Now that's it.